the front door. So today I want to go over a little bit about the about your term project presentation, and I've given out a copy of the schedule for that. The presentations begin a week from Tuesday. I've got a set of guidelines here which I wrote up a while ago. These are just my ideas and not necessarily definitive. How do I make full screen? I'm not sure how to do that. Can you read this okay or not? Should I? Down the bottom here. Not sure how to show all.
You might have to download it. Okay.
Yeah, I did that. So let me try that again and just load it up from where it was downloaded. Oh, it ends up the same place.
Yeah, it looks like it's using Internet Explorer rather than an Adobe Acrobat to read it. So
I'm not sure there's much I can do about this. Maybe there's a view thing. There's not much. Zoom, plus. There you go. That's better. Okay, so for your presentation, you have to use PowerPoint, or if you want to use an easily story map, that's also acceptable. We haven't had story maps before, but I've seen people doing presentations with story maps, and I'll show some after this that you'll sort of see why that could be useful. If you don't try to have any connections with ArcGIS Live in your presentation. I've had students try to do that before and kind of launch things from the screen, and it just doesn't work. If you've got additional files, animations or anything like that, embed them in your PowerPoint. Do not have files that are tagging along. Just one file. We just want everything in a single file. Put your presentation on Canvas, and if it's too big, well, bring it to my office, but I think it should be okay loading this into Canvas. Also, please put it on HydroShare as Dr. Taberton has suggested. You'll have 9 minutes for your talk, 8 minutes for the presentation, 1 minute for getting started and answering questions. So you might want to practice and time out what you're doing so that you can get what needs to be done in the time that you've got. Don't spend too much time on the introduction. Some people spend half their time on introducing their subject. Don't spend too much time on the introduction. Just 1 or 2 slides is enough, and then boom, just go for broke. People are visual communicators. And as I said before, you see things through your eyes much faster than you hear them through your ears. And once you're a deaf person, should understand your story just from looking at your slides. In other words, if you think about, have I got enough presented here, think about the story that somebody reading your slide set will get, because that's what they're going to do. And they're going to be half listening to you in the background, but they're going to be reading on the screen. That's the thing that will happen. So make sure that your slides have a message. It's not just, oh, here's a picture. What does the viewer get out of this? What am I supposed to learn when I look at this? I had a period in my life when I worked in Europe, in Austria. And this is a long time ago. And the language of science is broken English. And so there were lots of people who came from Russia and Eastern Europe and other exotic places. And so we had to learn how to present something so that somebody whose native language is not English can understand it well enough, or even who speaks in a weird accent like me. So, yeah, a deaf person should understand your story.
My accent is perfectly normal.
Yes, well, that's true. But my long-time assistant here, Sharon Bernard, said at my retirement event last Friday night that when she first showed up, she couldn't understand me. So maybe she got used to it later on. Apparently when I go to New Zealand, I come back and sort of talk more New Zealandy. But when I go there, they say, you sound like a bloody Yank. So I don't think my accent is sort of, it's not authentic to anywhere right now. You can make a storyboard that's useful at times. And the storyboard is you take a piece of paper and you divide it down the middle. And on the left-hand side, you write, this is what I'm trying to achieve. And on the right-hand side, you draw a picture or a sketch of what the viewer is going to see when they get that idea. And that way you're sort of thinking through your talk, and you're thinking, okay, I could have a picture of that, I could do this, I could have this, I could have this. And that way you can kind of plan out your talk before you actually make up the slides and sort of figure out the narrative. And this is probably the most important thing here. There's not time to say everything important, only what's most important. So particularly, it's not so much of a constraint for those who present early, but those who present later. There tends to be, oh my gosh, I've got my 16 slides with my this chart and that chart and some other chart. Just remember, only what's most important. A simple slide can be presented in 30 seconds, but a complex slide takes at least a minute. Don't have too many slides. I'm going to cut you off if you run over time, so just be aware of that. I've emphasized before using pictures and diagrams wherever possible that they're more effective than words. There are times when it's good to use words, particularly when you're having the introduction and conclusions. I suggest that having a maximum of 5 bulleted points. Do not have 10. Do not have 12. No. 5. If you think about zip codes, right? Zip codes have 5 and then 4. There's a principle of psychology that humans can't distinguish more than 5 things at one time. So in other words, if you've got A, B, C, D, E, that's what we can distinguish. Once you get to F, G, H, no, you go beyond the capacity of humans to distinguish separately once you get beyond 5 things. That's why zip codes have 5 numbers in them. So for each bulleted point, have a maximum of 10 words, preferably 5 or 6 words. Less is more. So if people see a big screen full of words, they go, and their brains just turn off. They just glaze over. So I often highlight in color 1 or 2 keywords that you're meant to get out of that. So when you see the slide quickly, you go, oh, that's important, that's important, that's important. Oh, now I've got some other words around that are telling me why that's important. It's okay to be nervous. When I was your age, I used to get freaked out about doing this kind of thing. I'd lay awake at night and I'm thinking, oh, I'm going to be a failure. This is going to be horrible. And I just stress out completely. And even when I was an assistant professor, I used to stress out pretty much as well. Later on, you kind of get used to it and it's okay. But it's okay to be nervous. That means you're focused. It's not bad to be nervous at all. If you're speaking early, it's okay for your presentation to be a progress report. And you can say, this is what I've done up to here, and these are things I still have to do. It's okay to do that. There's no bias really in presenting earlier or presenting later. I'll send you a grade and also an evaluation of your presentation. I'm sure your talk is going to be great. You are going to be super. Yes. Dr. Talberton, do you have any thoughts beyond what I've said?
Just a few things to add. Sometimes people like to use presenter view in PowerPoint. Don't do that for this class because what we see on the screen is exactly the same as what's projected because of the connection 2 ways. So if you're preparing notes, you'd have to bring them separately. There's a separate set of instructions, only slightly changed for the students here, because, for example, we are using the name presentation.pptx for the file, whereas Dr. Maidment has the files named by your last name. And that's so that, and you also only have to put your files in HydroShare.
Well, but hang on.
Then I guess I had a question.
David, let me just ask. So if I change this to presentation.pptx, that's going to simplify the process that you're in?
It will, because then when students go to the HydroShare page the page that I created that links into HydroShare, the link will work automatically.
Okay, so
if you're loading a file into HydroShare, name it presentation.pptx.
Okay. So let's call it presentation here.pptx, and I'll change this and put it back on the website with that instead of your name. Any other?
And then I guess I had a question about story maps. Where do students do them? Which server hosts them?
I think the ArcGIS online account at the university is the host.
It can create okay.
Yes.
And how long will that last? I guess if the term project is we've had people refer to term projects from 5-10 years ago.
So long as your account
Maybe we don't.
is active in the ArcGIS Online account, I don't see why it would be cut down. That would be if your account was wiped out, then it would be lost. Yeah, that's a good point. I hadn't thought of that. It's a little bit exotic to do a story map, but anyway, it's an option, I guess.
So anyway, I guess there was one thing. So if anybody does do a story map, I was going to suggest that you put at least one PowerPoint slide together, and you put in that PowerPoint slide the link to the story map, so that effectively the PowerPoint slide will be in HydroShare. It gives a place for somebody to click and find the link to your story map.
And let's make it a suggestion that you have a PowerPoint slide set that's a backup, just in case something goes wrong, because we haven't done this before, and although it looks attractive, it might be, we don't want to have a glitch on the day that messes it up for you. Any other suggestions? Okay, so Dr. Tarberton also had produced a set of instructions as to what he wanted to see in the project report, and I wrote out something similar myself. So this is what I've said here. Remember that this is your chance to be informing your classmates and Dr. Tarberton and myself about what your subject is. These project reports are going to be on the web, and in the final exam you're going to have to read project reports and make summaries of knowledge in particular areas, or say, I'm going to choose and contrast one paper with another, and here's the two I'm choosing. When I grade papers, I think of these three things. Creativity. How original is the project? Does it repeat what has been presented in class, or does it cover different methods and approaches? And I know some of you are doing hand mapping, so think about, well, how I could automate that, or go beyond what we've just done in class. Competence. What data sources have been used? How much technical analysis has been done in this project? What differentiates projects from one another really is how much work went into them. And it becomes pretty obvious when you read it, who's done quite a bit of work and who's just done a little bit of work. How well is the analysis being carried out? And then thirdly, presentation. Are the results clearly presented in the report? Are the maps clear and easily readable? Are there a well-stated set of conclusions? When you're on these things, it's almost like you get exhausted and go, oh my God, I've just got to finish this thing, and I'm at the deadline, it's 11 o'clock at night. Make some time to write a set of conclusions. What have I learned in doing this? What worked, what didn't work? If I reflect on this, what have I gotten? What have I come away with as a result of this? Some of the people that have really impressed me with projects that they've done in the past didn't come here as, gearhead engineers. Some came from who knows where. But they put a lot of effort into what they did, and they did interesting different things that were related to things that they were interested in themselves. So this is an opportunity for you to be you, to feel empowered and being able to present your area of knowledge in a better way than you could before. So any questions about this? Yes?
Question? Is there a general length that you're looking for? Can it just be whatever?
10 to 20 pages. If it's 10, I'd say, well, this is pretty light. If it's 20, it's pretty exhaustive.
Including like graphs and images?
Yeah, the whole thing. 10 to 20 pages is plenty. Dr. Tarberton, do you have any thoughts here?
I think this is a great set of advice, and I actually took your content and updated the instructions I had with this, so the students should go and check the new links on our webpage.
Okay. I was editor of the Journal of Hydrology for 4 years, and I made publication decisions on about 500 papers. And when you do something 500 times, you gradually get a formula. And in the end, this is what I looked for when I was making decisions about papers. Actually, I quit after 4 years because I thought I was getting too soft. I got to know everybody, and I couldn't, am I going to turn that paper down? I know these people. So, time for you to quit, guy. Yeah. It was a lot of work, too. Okay, so that's term projects. Any questions about presentations or anything like that? You're all okay? So I wanted to discuss today a little bit about demography. And you may say, what is demography? Demography is the study of people. It's And in the United States, that's done by the Bureau of the Census. And for a few years, I was chairman of the Mapping Sciences Committee of the National Academy of Sciences, and the Census Bureau was one of the sponsors of our committee. So I got to know them personally. I went over to the Census Bureau several times, and so I got some slides, and they made presentations to us, and I got some insight. Now, the Census Bureau does a lot of things, but the two key things are the decennial census of population and housing every 10 years that's used for political reapportionment, and the American Community Survey that's done continuously and has socioeconomic characteristics of the population. And the American Community Survey does all kinds of things, and I spent some time over the last couple of days researching out how to get into the American Community Survey, and I finally succeeded in finding the Rosetta Stone to do that. It's an enormous database, actually. So each month, 250,000 households are sampled, and that makes 3 million per year. The data are collected continuously, and then they make estimates, statistical estimates from those data. And you can get the one-year estimates, which of course can be most recent, but they have larger error in them. That's for fairly large areas. Then 3 years statistical estimates, they have smaller populations because they can estimate those with more precision. And then 5 years, which is the standard for the American Community Survey, you average everything over a 5-year period, then that becomes presented in the Census Block group areas. And this diagram you see a lot when you look at the census, and it describes how the census is made up. And the key thing to understand is that everything is done according to the political boundaries. So you've got states, you've got counties within states, so all the census data are conform to county boundaries. Within that there are census tracts, which are smaller units. Within that there are census block groups which average about 600 households in a block group, and then the smallest unit is the census blocks, which is 11 million of those. So here's just a time sequence to give you an example of what happens to census tracts as development occurs. So here's a census tract which is 1130 in 1970. And here it is in 1980, it becomes 1130.01 and 1130.02. And you can see there's more development here. Here it is in 1990. There's even more development. Now it's 4 different census tracts. And here it is in 2000. So it's gone to 4, 7, 10, 12. You can see the effect of urbanization. As the population spreads out, the census tracts are split up so that they get smaller and smaller. So there's lots of units inside of cities, and there's less out in the rural areas.
So is there a target number of people per each tract?
Yes, I don't remember what that number is, David, but yes, there is.
And do they restart the numbering? It looks like you had 1, 2, then the next subdivision started from 3 and on. So
yes,
they don't reuse the numbers, it looks like.
They make the numbers longer as they split them up. So, in fact, when you look at the census enumeration, you'll find that if they go back to this level, they have a bunch of zeros in there as well, just to sort of pad out the tract number. So that when you divide them up like this, they still can fit in the same space. Yes?
I think they divide it by number of households.
Number of households, okay.
Persons.
Okay. So that's true. It's a census of households and people, right? So yeah, it's and primarily the census is done of the households. I mean, the people are sort of a derivative number. So some time ago, I built up a geodatabase of the census for the whole country and added some attributes to that, and you can get that and download it. It's got populations from 2012 and population 12 per square mile, for example, there. Population in 2010. So if you want sort of the quickie version of the American Community Survey, which is the census block groups, you can just get it in that geodatabase. But while I was researching this particular lecture, I found this presentation by the Census Bureau, which was given in May of this year, and actually I thought this was pretty good. So let's take a look at some of the slides that are available there. So, yeah, I think this is it. So this is a presentation about how to use the American Community Survey in geodatabase files and in ArcMap. So it talks about the basics of the American Community Survey, and there's a whole series of topics here. There's some description here about the nature of the census, more or less the things that I had indicated before. And I thought this chart was really interesting. So what this shows is that the census has been going on for a long time. It started in 1790. I guess it was important even then to figure out how many people there were. So right after the United States became a country, they started doing a census, and they had one form for all the households from 1790 to 1930. And then after that, they started splitting things up so that there was a short form and a long form. The short form was like just how many people are in your house and things like that. The long form had lots of economic characteristics, and some households got the long form, a sample, and a lot more everyone got the short form. Then that evolved in the 1990s to this concept of the American Community Survey, which is a statistical survey. And there's a distinction here between a survey, which is some of the things, and a census, which is everybody. So a census takes into account everybody. The two key words here are census and survey. So over this period, they started testing the American Community Survey, and after that, from 2005 onwards, the American Community Survey was used as the mechanism for getting socioeconomic information, and instead of having a short form and a long form, just the short form was used in 2010, and it will be used in 2020. And they had a slogan, 10 questions in 10 minutes. That's the short form. So this is how the census has evolved over time. So the American Community Survey is different from the census, and the American Community Survey has sample estimates. They also have the error of each estimate presented in the data, and the census is the official count. So there's no margin of error given there. This has to do with the population characteristics, descriptive things. This is just the number of people. American Community Surveys every year, census every 10 years, and collects, as what's indicated here, various ways of going about the American Community Survey, and it has lots and lots of things, and I'll show you in a little bit how to get into the data. When you're looking at these tables, it makes your eyes just glaze over immediately. They've got these obscure numbers, but the numbers are put together with a particular structure, which is illustrated at one example here, and I'll show some more subsequently. Here's the same hierarchical system that I showed earlier with regions, states, counties, census tracts, block groups, and so on. As the census, the American Community Survey increases in time, the number of people that are being measured decreases. And yeah, there's some more information, blah, 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 location census database. Okay, so this is what I found to be really helpful. I couldn't figure this one out actually, but when I got to this point, the Tiger products, and particularly when I got here, when I got there, this particular place, this is where I got to the place where I found just the right hole to drill. It's like these things, if you find the right hole to drill, you're gold. And this is the right hole to drill, right there. And it was there that I got the 2012 to 2016 American Community Survey. Downloaded the geodatabase. You can put in a state here and get a geodatabase for a state, which is what I did. It pops up, it downloads the files. Then you can join the feature classes to the tables. So you take the geodatabase, load that up, take the tables, and then do a table join, and then you can make maps. And yeah, so this is basically stuff that you already know how to do. So I went through that, and I succeeded in getting the data and downloading it for Texas, and it was really helpful. I feel finally I know what I'm doing now with how to get the census, or how to get the American Community Survey. So what I did was I went to this place where the Census Bureau, I got the Tiger files. You can see there's different detailed tables here for different periods. I got the 2012 to 2016 detailed tables. I put in here for the case, get the database for Texas. And what you get with that is a set of shapes. You can see the Dallas-Fort Worth area and so on. And they're indexed by this attribute called geoid data. On the other end of the table, just there you can see it. There's also a number here, geoid, but this is the one that's used for doing the relationship forming. So you start off here with just some geometries. There's no attributes attached to these features. And then also in the package that in the
It's like the
geodatabase,
use of geoid as an unfortunate name clash.
yes, I guess it should be GeoID. That's really what they're trying to say here.
It's not the same as the geoid we've been speaking about before.
That's true. That's true. You're right. So, so in the geodatabase, you have the geographic data here. You've got a big file here called the block group metadata, and then all these X tables here are the different attributes of the census. Now, I translated that into an Excel file so that if you want, oops, I guess I'll have to change the link there, but anyway, I translated that into an Excel file so that you can look at this. There are 7,731 variables and 21 tables. So when you're building the maps from the census, what you do is take the American Community Survey geospatial representation and take this geoid data variable, and then take the attribute table here, which in this case I've got income, and you've got this thing called geoid ID here, and you can see those things are the same, and you join those two things together, which means you get this enormous table, and you've got lots of columns here that have B 1900, 1M1, 1901, E2, and so on. E means the estimate. In other words, this is the real number. And so the variable that I was looking at here was the median household income in the past 12 months in inflation adjusted dollars. So this attribute, B19013 E1, says that in this particular block group, the average or the median income was $53,657. And that M1 is 3140. That means the error of estimate of this number here. So what I did was I went through and figured out from the table something that I thought would be interesting, and then I did the table join, and then I made a map. So I just symbolized by the required attributes. So you can see the darker blue areas here where the income is higher in the main cities, and the lighter blue and the green areas are out in the rural areas. This is another map that I made, the total population by block group. And in this one, I succeeded actually in creating a new attribute. So what I did, I just put total population, and I then joined the tables together. I did a calculation in which I took the weird attribute that was really where the data were, and I copied it over and put it into total population, and then I undid the join, and I had my data with just the variable that I wanted. I tried to do that with the income information, and for some reason it just kept blowing up and saying, can't get the lock. There's something about the lock. I couldn't figure out how to overcome that. Sometimes that's because the files are only read-only files, so you can go to the properties of the geodatabase and say, is this a read-only file? And if it is, then you click that off, and it becomes that you can read things. So sometimes things don't work in ArcGIS because you're trying to write into a file that, because you downloaded it from the web, is a read-only file. So you can overcome that by copying the data into a local geodatabase that goes with your project, rather than using the data that you directly downloaded. I tried that with this income data, and I still couldn't get past it. So if you join the data together and then you export it into a geodatabase, what you will have is the entire joined table, which is now a new geodatabase all by itself, a new feature class with lots of attributes by itself. And that is probably the way you have to do it if you run into trouble with these log files. Here are some analyses that I did with census block groups in Travis and Williamson counties, and I've used here the FIPS code. FIPS stands for Federal Information Processing System, and it's really important to know these FIPS codes because that's the index for being able to pick out particular counties or states when you've got a large amount of information. In this instance, 48 is the FIPS code for Texas, and 453 is the FIPS code for Travis County. So within Texas, and to get Travis County, it's 48, 453. Similarly, 491 is the FIPS code for Williamson County. So 48, 491 is the combined code for Williamson County that you can isolate it from all the counties in the country. So here's a breakdown here. So Travis and Williamson County are two counties which together have 307 tracts and 823 block groups. You can see how the tracts and block groups are finely subdivided in the urbanized areas. So this is the thing that's different about demographic analysis than what you've been accustomed to doing with watersheds and all that. Is watersheds are like, it's uniform all over the landscape. Every natural areas, rural areas, and urban areas get treated the same. With demographic analysis, it's not like that at all. The urban areas get treated in a much more refined way than what the rural areas do. And indeed, in some cases in the rural areas, there are just huge areas that are treated as block groups and uniform and character. Here's some demography here local to our campus. So here's a census tract. So this is just right here is ECJ. You can see that, yeah. So here's the Dean Keaton or 26th Street. So let's see, there's Speedway. So yeah, our building is right there. So that's a census tract is basically the campus and the area north to the campus. And then that's broken into two blocks here. So the tract is 48453, which is Travis County, and then 000601, so that's the census tract, and then the 000601 has block group 1, which adds a 1 at the end here, and it has block group 2, which adds a 2 at the end here. So you can see that these numbers are built up: the state, the county, the tract, and then the block. That's how the group numbers are made. Something that I've found particularly helpful is this thing called the USA Census of Populated Places. So quite often I want to make a map and I want to know, where's Phoenix, where's Austin? Just this morning I was talking with Emily Luama about her project, and she was dealing with Lake Conroe, and we wanted to find out where are the communities just downstream of Lake Conroe. So we just opened up the map, and then I added this USA Census Populated Places, and we found, okay, Conroe is here and Kingwood is there, and okay, we probably need to look at the impact of flooding in Kingwood. So this is a quick way to sort of find where are places that I would be interested in and where are the urbanizations. So this is a census function that's different than the American Community Survey and the Census Bureau. They basically go around and they compile the constituency boundaries of the populated places in the country. So I put one there for Logan, which goes down as far as Ogden, I guess, and the one here for Austin and its surrounding areas. There are other maps in the Living Atlas, and I'll show you one. And many of them are image layers, which are not very good for. Now I have to sign in here because this is in our ArcGIS Online account. So there are many image maps in ArcGIS Online, and you can see they're very nice because you can zoom them out to a large. You can see here's the census block groups, here's the tracts, here's the counties. At this level, it's just the states that you can see. So if we zoom in a little bit, then...
Do you know what the different colors are? Because I guess Utah was blue and Texas was orange.
Okay, that's a good question. So let's see, the legend. Then we should be there. Legend, okay. So...
income.
income. Yes, this is household income, so it looks like Utah is a rich kind of a place.
Interesting. I would have thought it the other way around.
Well, I guess so, yeah. Well, and particularly northern Utah. Look at that Logan area. That's a really rich place. Is this where you guys
No,
are?
that's the Uinta Mountains. I don't know. Logan's further north. Where that is. Where that is.
Yeah, so anyway, as you can see, as you zoom in, you get greater or lesser degrees of detail, starting at, I guess that's county scale. Well, yes, counties. So if we zoom in, yeah, you can see it says tracts there now. Maybe if we zoom in even further, do we get to block groups? Yeah, block groups, I guess. So let's go to Austin. I always like Austin. I know where I am. I know what I'm talking about when I get to Austin. So here we have, so this is the Austin San Antonio area, and you can see the different areas of Austin here. So this is Travis County, and you can see that there's a pronounced income disparity here between West Austin and East Austin. And the thing that's nice about these, so this is at the tract scale, and then we zoom in far enough, yeah, then we get to block groups, as you can see here. Now the thing that's nice about these image maps is that you can click on an image map and there's pop-ups. So there's quite interesting pop-ups here. So it says, for the 15-18 households in this census tract, the median household income was $25,000. That's 50% below the US average. So there's like a little chart here. What get directions means, get directions. Driving time. Oh, I guess you can drive there if you want to. And so if you just want to make just discrete oh, look at that. 33 minutes. Who knew? I didn't know you could do that. Well, look at that. Well, that's cool. Now here, get direct. Okay, you can plan out your route. Who knew? Okay, this is cool. So Esri's put a lot of work. If you look in the Living Atlas, you'll see zillions of layers that are associated with the census. They put a lot of effort into sort of smushing up the census into easily consumable bytes of information. They call this geo-enrichment. Yeah, you can have geo-enrichment. It's kind of like, you know, I'm richer than I used to be. But the nice part about this is that you can make these inquiries. Now the downside is that you can't get out the data this way. It's basically, this is just for querying. It's not for, you know, downloading a whole bunch of data and getting them and doing analysis yourself. However, it is nice that these maps exist. So this is one for household income, population density. So here's a map for population density, and you can see the denser areas in Austin are in the center of the city, and the area, things get less dense as you go further out. This is one for median age, and it's an interesting map. So what do we learn if we look at this map? Young people. So where are all the young people living? Yeah, east and north, right? So the center of the city is in here. So the young, well, I guess in here, the young people living east and north. So where are the old people living? Southwest. Yeah, in the west. Yeah, that's where I live, yeah. So I'm living out here in Western Travis County. So, and what about this one up here? Yeah, it's a retirement community. This is Sun City or something up there. It's a big retirement community in that area. But these kinds of maps are important when if you think about them. Why is that distribution important?
This is, a lot of this is the age that people start thinking about having kids, and so that matters for school size, number of teachers.
Okay.
And their income levels would matter for them as well.
Paris.
to take decisions so that the government can get decisions about how to disperse social services
Uh-huh.
and
How to disperse social that's true. That's a very good question. Another is in emergency response. Why does this matter in emergency response?
The most fragile.
Yes,
in society.
the old and young are the most fragile. So if you have an emergency, you've got to allow for that. In Texas, we have something called STEER, which is a statewide database that if you're handicapped and if there's an emergency, you have a wheelchair or something like that, you can actually register yourself as like, I need help to get out when there's an emergency. Similarly, if you can imagine if there's a flood, if you've got lots of young people and particularly young children, then they're very vulnerable during the flood. So median age is a critical thing. Percent of the population 65 and older. Vote Republican, yeah. Lots of conservative people out near where I live. When I go into the gym, I see Fox News on the TVs in the gym there quite a lot.
It seems like for emergency response, you'd need something about the distribution of age because lots of children, college age would say a median aging of 17 or 18 would be really good at getting out in an emergency, but if you've now got 25-year-olds with sort of 2-3-year-old children, it's more. And does this give anything about the distribution of ages?
Yes. So the census is done in age brackets, I think in 10-year brackets. So here is the percent of the population 65 and older, and this is the percent of the population under age 18. And in fact, there's a series of levels in between that. So I just picked a couple of cases here. So this is one thing that the census pays particular attention to, is what is the age structure of the population. And the population growth rate. What does this chart tell you?
North is growing much faster than.
Yes, so you can see that the big growth areas here are actually in Williamson County. So Round Rock in that area, northeast Austin, Pflugerville and so on, that's growing really rapidly. The pink areas here, where are the pink areas?
maybe some forest area.
Nope.
Campus?
That's downtown Austin. Yeah, this is the older part of Austin. So what that says is that, the older part of Austin isn't growing. It's established, it's fixed. There's not a great population growth in the older part of Austin. What's happening is that the population is increasing in the suburban areas to the east and the north and the west, south, but not in the urban area in the centre. So this is actually kind of an interesting phenomenon that you've got the urban core is actually fairly stable in population, and the growth is happening on the ring that's around the urban core. Average household size. What are we learning here?
Bigger families are in the east.
Yeah, big families in East Austin, some in the north also, and smaller families are in the west. So there's lots and lots of, you can sort of start to get a feel for digging in. There's just multiple layers of, well, I guess this is, there's a series of additional items here. But you can get a sense of this sort of multiple dimensions of the human population and how they're reflected in the information that's provided by the census. Median household income. This is the chart that I was making for the whole state. There's some interesting demographics there. So there's lots and lots of information in the Living Atlas that you can just poke around and get a sense of what's involved with the census. So what we've talked about so far is just the American Community Survey, but I want now to speak about the census itself. So here's the census tracts in Travis County, and then here's the census blocks. So we go from 218 census tracts to 15,922. So there are an average of 73 blocks in each tract. And here's an example of what a census block looks like. So each of these black areas here, these ringed areas, that's a block. So you can see that there's a set of houses here, individual houses along a street, perhaps 20 or 30 houses. And these blocks are set up so that there's some consistency in the number of houses that are within each block. And here's a more detailed example of a census block. So you've got state is 48, the county FIPS is 453, the tract is 01761, and the block is 2006. Why do you think they use blocks? In doing the census, the data are compiled by blocks.
It's a lot of money to do a survey of this scale.
Yes, it's a lot of money, but there's another reason that the data are summarized like this. Gerrymandering, yes. Well, that too, yeah. So the numbers are produced for the block, they're not produced for individual houses. Why is that?
For privacy.
Yeah, for privacy reasons. So the data are summarized by blocks for privacy reasons, so that you can't determine what was the information contributed by an individual or a set of people in a particular house. Among other things, there are some people who just like to live off the grid. I mean, who don't want to be messed around with, actually. And so, yeah, the data are supplied, measured by blocks. In this case, there's 38 houses in the census block. And evolving from some analysis that I'd done before, I found that the census block information is available by state at this location. So if you just go to the www.census.gov TIGER and click on a state, in this case I clicked on 48. Actually, I think Utah is 50. So Utah is quite close to Texas here. And you can get all the census block information for a state. And this is what the census blocks look like for Texas. There's 914,231 of them. And if you can isolate the census blocks that are in a particular county by just doing a selection that goes by county is 453. So here you can see the county FIPS number, and here's the state FIPS number. In this case, because we've got data only for Texas, we don't have to bother about using 48, 453. We can just use 453. Now, I have no idea how this number 453 got figured out. It is what it is. And if you do that, then you can isolate the census data for Travis County, and I just made a query here and isolated one of the census blocks. And in this case, I found that this was State 48, County 453, Tract 0001768, Block 1003, and it has housing units 103, and it has population 229. So this says there's 103 housing units and 229 people in this particular census block in the 2010 census. So you can make detailed calculations at the block level with this information now. The data set that I downloaded has only housing and population. It doesn't have ethnic distribution and other things that the census also carries. And so one of the things that I was working with Rigel. Where's Rigel? Yeah. So tell us what you were doing, Rigel, and why this was important.
So one of the things that I was looking at is how the number of people affect population exposure, and I needed this information and couldn't find it for 2 weeks.
Yes, so what Rigel is doing is he's got points along the streets of Austin where air quality has been measured in Google cars or something, right? Yeah. And so what he was trying to do is, okay, how do I know how many people have been exposed to air quality of a particular level and also what was the land cover in this area. Now, can I correlate the air quality with the land cover that's in this area? So by getting the census blocks, and he was able to make some progress, but then there was a complication about the streets.
Yeah, so most of the blocks are divided along streets, and that's where we have our measurements. And so it becomes difficult to isolate which block a particular measurement is assigned to.
Uh-huh.
So I need to figure that out. Yeah, I have.
Okay, so Rigel's in a particular part of his term project where he's trying to figure out, if he's got measurements in all these grey areas here, or grey rides, you know, how do you associate them with the block when lots of them are on the boundary? But anyway, I guess you'll inform us about that in due course, Rigel. So, but anyway, I was really pleased to sort of figure all this out again, because I've made a couple of attempts at this in the past, and you know, I got into the situation that you were in, Rigel, just, oh my God, I just cannot find this, but yeah, I managed to find it. So, sorry, David, you were going to say something?
No.
So here's the same data now tabulated by population and housing units across Travis County, and I've done some summary statistics here that on average the number of people per housing unit in Travis County is 2.32, so some average size of a household. Another thing that I thought was interesting was to figure out what's the population in the San Marcos Basin. And we worked out this San Marcos Basin, we did lots of hydrology there. What about the people size of that? Another thing is the Edwards Aquifer, which underlies the San Marcos Basin. So here's the San Marcos Basin, and if you put out all the census blocks, then we can use a function called clip, and we can clip out the census blocks that lie within the San Marcos Basin and add up the population from that. There is an error associated with doing that, though. What is that?
The edges of it could possibly be cut in half.
Yes, so Clint is right. On the edges, when you do a clip, you're actually cutting the census blocks in half, or by some proportion of them. And so if we take the attributes of that census block, it could be that we're overestimating, because some of it's outside the boundary and some of it's inside, and we're counting all the people as being on the inside of the boundary. So how could you get around that?
Any ideas here?
Sort of a weighted average.
Speak loudly.
A weighted average?
Sort of a weighted average.
Okay, but how do you do the weighted average?
Question.
Good question. Okay, there you go.
You know your boundary polygon, couldn't you just do extract by mask at that point?
Extract by mask. Extract by mask works on rasters.
Rasters,
Yes, so this is all vector. But that's true, that if you follow that thought along, you could go there. So you could convert the raster to a vector, but perhaps rather than having population, what should we have instead?
Density.
Yeah, density, okay. So how do we get density?
Dividing by the area.
Yeah, by dividing by area. So a better way to do this is, instead of just taking the population, it's to take each polygon has an area and have it in projected coordinates. And if you divide the population by the area, get population per square mile, then you can convert that into a raster, and then you can use extract by mask, and then you've got a density, population density rather than a population. So that is a way of doing it. And in fact, when we had an exercise like this earlier on in the semester, what exercise do we do that was like that?
The rainfall one.
Yes, with rainfall, that's true. This is like sort of Thiessen polygons and rainfall, but also there was something else earlier than that. What else did we do earlier that was like this if you use extract by mask? Yes. Let's see, that's true. We did it. Well, we didn't do extract by mass or evaporation, but the next exercise, on exercise 2, what do we do with extract by mass and get areas?
Is it when we limited the streams to the basin and we only looked at the streams within?
No. I got messed up. Remember, I didn't project the grid correctly. It was the land cover data. Remember the land cover exercise where we extracted by mass and we counted the number of cells and then we multiplied by the cell area to get the total amount of area. So this thing, if you did the convert to raster and extract by mass, would look like the land cover calculation that we did earlier. So there's some things that you can do with census data, but you've got to be a little bit careful about the way you go about them. So I've put a little note here that says, CLIP slightly overestimates the population since it includes all population in clipped polygons. So it can compute population per square mile and then multiply by the clipped polygon area to get a better result. So this would then correspond pretty much exactly to the precipitation exercise that we did earlier with Thiessen polygons and so on.
So I would ask if anybody thinks there's an assumption there that you might also want to question.
Okay, what's the assumption?
Constant population density.
Yeah, constant population density, yes. So yeah, we're assuming that the population density is uniform over the block, which of course is also not true. But by the time we get this many blocks, it's perhaps not such a big problem. Here's a similar kind of thing for the Edwards Aquifer, which is main water supply for San Antonio and parts of the other areas. And one of the things that's sort of fascinating about this is look at how large the census tracts are in the rural areas. So you've got these huge areas, not very many people in them, and then how tiny the census tracts are in San Antonio and Austin. So you can see how largely differentiated the census is when comparing rural areas with urban areas. So let me summarize here about demography. So the demographic data are compiled by counties. This county contains census tracts, the tracts contain block groups, and the block groups contain the blocks. The American Community Survey is compiled by the blocks, and it's a sample, and the population census is a complete enumeration, and it's compiled by the blocks. And I put these two links here to point to where you can get the information for the American Community Survey and for the census. Yes, Paras.
How do they decide that we have to cover this much rural area, this much area of land? Is it on the basis of the number of people?
Yes. So, so the question is, how do you decide how much of an area is to be covered?
In a block.
So I'm sure there are criteria. There's about 600 households in a block group, and I showed how many households were in that block, and maybe 30 or 40 in a block, something like that. So that's sort of roughly the proportions. Now I'm sure that there are criteria about that. The Census Bureau has been worrying about this for decades, and so a part of the consequence of converting to the American Community Survey was to put the whole problem on a statistical basis. So they're actually, when you get it onto a statistical basis, they're actually taking larger areas and then making smaller ones because they're sampling over it, they're merging areas together. I don't know all the details of that. I know that inside the Census Bureau they have 300 cartographers. Yeah, they have a employment classification called cartographer, and there's 300 of them. It's the largest concentration of mapping people in the whole federal government is in the Census Bureau, and they worry about stuff like that. Any other questions about the census and about the population characteristics? Are you excited about the census? Excited about it? Yeah, isn't that cool? It's a huge amount of information. Would be great for a final exam too, don't you think? No, just kidding. Dr. Tarleton, any thoughts or?
I think it'll be a good final exam question. How many people are in your watershed?
Yeah, I mean, I think this is there's a sort of a yin and yang thing about this, right? We've been studying mostly the natural environment, but understanding the people side of it is really important as well. Okay.
How many people live within a height of 10 meters above the drainage?
Okay. There you
Below
go.
10 meters. So there we go. So
Okay.
you're coming up with ideas here.
I'm glad to hear that. Okay, so the last thing I want to do today is to talk a little bit about story maps, and I was inspired to do this first of all by a story map. This is one that we're doing on a project that we have for the Texas Department of Transportation. So these are places where we are thinking about putting measurement sites on TxDOT bridges. And so we've gone through, a couple of colleagues, Matt Abels and Harry Evans, have done a field reconnaissance at a bunch of places. So you can see this is one of our sites, Cibolo Creek at the I-10 frontage road. We're instrumenting I-10 here. And this is the location is on the upstream side of the left bank of the frontage road bridge. And there's some photos that they took while they were there that are noted here, upstream and downstream, where they're going to put the equipment. They've done some measurements here, and then you can go to site 2, for example, and we can go to a different site, and you can see another map here. Now, the interesting thing about this map is that it's scale dependent, so you can just zoom out and say, oh gosh, I think I'd like to see more about where this place is in context. Oh, here's all of Texas. So here's all of our bridges, all the sites that have been surveyed. So each of these maps is a scalable map, and each of these individual bridges focuses just on one particular location. And so this is proven to be a very useful summary guide for our project, where instead of having PowerPoint slides and having everything, the usual way we do things, by linking these in a story map, we've been able to create a composite set of information that stores the information that was taken each time somebody went out to one of these sites. These blue dots here are something called the Texas Inspect Tech. So inside of TxDOT, they've got this enormous database called Inspect Tech. And they're Inspect Tech people who worry about Inspect Tech. And they inspect these bridges every 2 years. So if you want to worry about, is our infrastructure falling down? Well, TxDOT has contractors, and they send them out. And there's a whole army of contractors. There's 55,000 bridges total. And you can see this particular bridge has 4 spans, and those are counted as 4 separate bridges. Each of those spans on the main highways is $2 million. So if you have 4 of them, okay, you're looking at $8 million for a modest structure. That's why putting a stream gauge on it is not that much big of a deal for them. And a part of what they do when they do the inspections is they go along the bridge and they drop a line down into the bottom, or actually use a depth sounder and sound right across the river. So they're actually measuring the depth of the river every time they inspect the bridge every 2 years. And why do you think they do that? What happens to bridges occasionally?
Breeze.
Rust.
I'm sorry?
Rust.
Rust, yeah, they can rust, but if they're measuring the bottom of the channel, why are they measuring the channel?
For erosion?
For erosion, yeah. These bridges can erode. Why would a stream erode? Well, in the Sulphur River in northeast Texas, there was a really good project to straighten out the river and avoid flooding in swampy areas. What happens when you straighten out a river? It runs faster. What happens to the bed of the river when it runs faster?
Erosion.
It erodes. So all along the Sulphur River, the bridges all got exposed. You straighten out the river and suddenly the foundations were not deep enough anymore. So the TxDOT measures these kinds of statistics and also all kinds of other things about bridges and puts them in this database called Inspect Tech. So I thought this has been very helpful on our project. Also, when you're looking at each of these sites, you can get a sort of a sense of context of what's around it. And also, where are we in relation to other things? This one's near Sabine Lake. This is actually a pretty big lake near the Texas-Louisiana border. So this is one story map, and then another story map was compiled by a colleague, David Arcter, who built this up for Hurricane Harvey. Do you want to give us the commentary here, Dr. Tarleton, because you're the PI on the project?
Well, I'll say what I can, but you might need to add because you were actually on the ground when it was happening. So the idea was to try and get, after Harvey had happened, there was a wealth of data that had been looked at in the Emergency Operations Center there, and Dr. Maidment was there doing some of the analysis. And the idea was to try and collect some of this data and make it publicly available for people who wanted to do research on perhaps mitigating or planning for events like that. So this story map was part of the building up of that collection. It was organized through the Consortium of Universities for Advancement of Hydrologic Science, and the data itself was put into HydroShare. And as you can kind of work across the tabs at the top. So this is a different type of story map to the one we saw before, where you sort of scroll down the table of contents on the left. But each tab at the top will give you one set of information. So there, for example, you see the flood data, and if you read that and you zoom in on that, it'll tell you that those are locations where they actually surveyed high water marks, I believe, from Harvey. And there, somewhere there, you can actually click and get to the HydroShare resource that will have the actual data involved in it. So I think if you, so that'll take you to the HydroShare resource, and we'll have to wait a minute for it to load. So those are the, explains it's the flood depths, flood extents, and well, this is actually a collection of resources. So in HydroShare, in addition to just having a data like you guys are doing for the term projects, you can also make a collection. So maybe when the class is over, we'll make a collection of all of the resources from this class, and then you can sort of have them grouped together. If we clicked in one of those collections, we might have been able to find the individual data. So maybe it says click here to review and select data to download. Go back to hydrology. Okay.
Okay. So let me. I'll go.
Well, let's just let it go to one of these and see if there's an interesting one too. So maybe you're interested in FEMA flood depths grid. So click on the FEMA flood depths grid one. And there you've got an explanation of it, a whole bunch of references for where it came from. You should see there's a GeoTIFF file that says it's a 3-meter grid, and you could probably download that. It might be a very big file.
So you download it here, right?
Right. Mm-hmm. It may tell you it's too big, but you can try.
Well, I won't download it, but when you do that, when you get to this point and you download this, do you get just the content of that portion of the collection?
You get just this resource within the collection. Yes.
Okay, that's important. Yeah, because there's quite a lot of different files here. So some of you want the address points, so we need to find the place which has got the address points in it to find that. So.
Right, so look for address points is the tab across there's an addresses and boundaries.
Okay, so if we go
so you can get the addresses grouped in those different boundaries.
So if we come here, addresses and boundaries.
So
okay.
So there you can find the address shapefiles. You can get an address geodatabase.
Okay.
And if you wanted to do something like the exercise we did for Onion Creek, but over in a different part of Texas that was within the area covered by these addresses, you could get them from here.
So some of you are doing projects that involve, like Emily is doing, this is where you can get the address points that you need for being able to look at the extent of flooding and then who's going to be impacted by that. So this is actually a really interesting example of of the use of HydroShare. You can see there's a plethora of information that's being stored here. Information about hydrology. And this is the drainage areas that were impacted by Harvey, for example. So there's a whole series of here about the drainage areas and the regions that were impacted by Harvey. Transportation, the road network, and fantastic amount of information there. Vulnerability, this has to do with social, the social vulnerability. So SVI stands for Social Vulnerability Index. It's part of the American Community Survey. And here's data about, where are the socially vulnerable populations. So if you go to Houston, for example, and zoom in, you find an interesting pattern here. Where are the socially vulnerable populations in Houston? What does blue mean here? As socially vulnerable. And this green color, that's the rich people. Yeah. Harvey actually blitzed this area, so the rich people got, it wasn't discriminatory at all. But anyway, this is the idea of socially vulnerable populations and so on is a key piece here. Hand, what have we got for hand? So these are so click here to learn more about hand.
Yeah.
And if you come down here, there's a whole series of information about the National Water Model hand data. We built this basically as a resource that could be accessed all over the country, and this is a piece of it for this area. And Harvey Stories. So this is actually a story map that links to a story map. So this is actually comes from the National NISGIC, National Center for Geographic Information Systems for Public Safety. Well, it's going to take a while to come up, but I'll just leave that. And then, isn't that cool? Actually, that map was made by, that's one of the FEMA maps, but I think David just put it in there because it was such a cool map. But if you look on this side, you can see there's an inventory of data. So addresses and boundaries will take you directly to that resource. So anyway, this is an example of a story map that's really a compilation of data, and it provides a map interface to the information resources that are in HydroShare. Okay, well, let's quit there then. Any last thoughts, Dr. Tarverton?
No, I think this is good. We're looking forward to counting how many people are in all your different study areas.
Okay, thanks so much then.
It's the code. You don't even know.